This is Varsha's Education Academy. Let us see the first example problem in steady state error. See, this is very important problem for all competitive examination, but very simple concepts and very important. These three formulas you should remember. Then no need to see again before the exam. You should remember all three formulas and the tabulation. That one is essential for writing this, for remembering this concept. For a unity feedback control system, the open loop transfer function g of s is equal to 10 into s plus 2 by s square into s plus 1. Find Kp, Kv and Ka. What is Kp? Positional error constant. What is Kv? Velocity error constant. And Ka is acceleration error constant. So solution for this problem, see here they have mentioned unity feedback system. What is g of s? Generally we used to write the transfer function as g of s into h of s. And for a unity feedback system they have given. So unity feedback means h of s is our feedback signal. So h of s is equal to 1. Unity means 1. So h of s is equal to 1. Then given system is, what is the type of system? What is meant by type generally? So number of poles at the origin. See here the number of poles is s power 2. So there were 2 poles at the origin. So the type of the system is type 2 system. So type 2 system, refer our previous video for that tabulation. For type 2 system, the positional error constant is infinity. And the velocity error constant is infinity. And the acceleration error constant is constant value. Okay. See in the tabulation they have given that 1 by Kp. So 1 by Kp is equal to 0. Upper Kp is equal to infinity. Then next value for type 1 system, for type 2 system velocity error constant, that is unit ramp signal, Kv is 1 by Kv, so that is 1 by infinity which is equal to 0. So Ka is the only term having constant term. Let us solve this problem and we can realize these answers. But this is our final answer. Now we should find this constant value for the problem. So Kp, formula for Kp is limit s tends to 0 g of s into h of s. Kv, velocity error constant, limit s tends to 0 s into g of s into h of s. Ka, acceleration error constant, limit s tends to 0 s square into g of s into h of s. Now let us substitute in these formulas. First let us see Kp, positional error constant, limit s tends to 0 g of s into h of s. See here h of s value is for this problem. Why? Because 1. They have mentioned that the system is unity feedback control system. So g of s into 1. Limit s tends to 0. G of s what they have given we have to write. So substitute all the value of s is equal to 0. So 10 into 2 by 0. So denominator we are having 0. So what is the value of Kp? That is infinity. Anything by 0 is infinity. Next velocity error. Next one is velocity error constant. That is Kv. Formula for Kv is limit s tends to 0 s into g of s into h of s. So s into g of s instead of h of s we are substituting 1 for a unity feedback control system. So limit s tends to 0 s into 10 into s plus 2 by s square s plus 1. See here s and s get cancelled. So remaining one more s here. After substituting s is equal to 0 we are having denominator. In denominator we are having 1 0. So 10 into 2 by 0 is equal to infinity. So Kv is also equal to infinity. Next we will see acceleration error constant, that is Ka. Next acceleration error constant Ka is equal to limit s tends to 0 s squared into g of s into h of s. So we need to substitute h of s is equal to 1. So limit s tends to 0, s square into 10 into s plus 2 by s squared into s plus 1. S squared get cancelled. So we are getting 10 into 2 by 1, which is equal to 20. So this is our acceleration error constant, that is constant value. So let us substitute, let us write the final answers here. Kp, that is positional error constant, is equal to infinity. Kv, velocity error constant, is equal to infinity. Ka, that is a constant term we are getting, which is equal to 20. So this is our final answers. This is very important problem for all the competitive examinations. Please go through this problem while going before the exam. Thank you all. Thank you for watching this video.